start on our interactive light switch then, let's first of all tackle the problem of just which light switch the user is actually looking at in the level, which we can do quite simply by means of a line trace. Inside our content browser then, we will first of all want to make sure that we are inside the level_BP folder, where we can double-click on the first-person character blueprint, which is a blueprint that is created automatically whenever we use the first-person template in Unreal to create a new project, something that was used for this example file. We are going to put the line trace in this blueprint because it relates to an action that the player will take. It also means that we can update player interaction, which even in this course will include things other than the light switch, in an easy manner. To make a start, in the Graphs section of the My Blueprints tab, let's click to create a new graph. Call it Line Trace, and then press the Enter or Return key. Because we may want to add a number of events that the line trace can control, it is typically a good idea to keep the logic separate from all of the locomotion nodes that reside in the main graph. Now this will help make editing easier and less confusing whenever we come back to the blueprint. To add the location of the line trace, we can left-click and drag on the first-person camera component to add it to our graph, after which we can click and drag from its output, type Get World Location into the search field, and then add the node of the same name from the transformation section. This reference to the first-person camera component will ensure that the line trace always originates from wherever in the level the player is viewing the scene. We get this start point from the Get World Location node, which, as its name suggests, gets the location in world axes of the current target, in our case, the camera. Now that we have its start position, we can once again click and drag from the first-person camera output, this time typing Get Forward Vector into the search, after which we can add the node of the same name and position it below our Get World Location node. We need the forward vector of the camera, as this will let our blueprint know in which direction we want our line trace to travel. It needs to start at the camera, so the Get World Location node, but then it also needs to travel in the direction that the camera is looking, hence our Get Forward Vector node. We do need to tell Unreal when to put both of these nodes to use, of course, and so, coming to the Edit menu, let's click on Project Settings, and then come to the Input section, where we should see the Interact entry, along with its associated buttons and keys, which is where we can set up a number of predefined key combos that will execute when a particular set of command keys are pressed or used. In our case, things are set so that mouse 1 will be the key that runs the Interact action. Once we know that our action is set up, after closing the Project Settings window, we can right-click in the graph, search for Input Interact, and then add the custom event inside the Action Events rollout to the graph, placing it above our Get World Location node. In other words, whenever we press the first mouse button, this event will fire and execute any nodes that are plugged into it. In our case, this will be the line trace that will drive our interactions. Let's hook that up then by dragging out from its pressed output, and then searching for a line trace by channel node, which we can click to add to the graph. This node will shoot out an invisible ray, to the eye that is, which can then be tested and return all sorts of useful information to the blueprint. A very powerful node that can be applied in a wide variety of situations, specifically in our case, to see if the player is looking at a light switch. At this moment in time, however, the line trace node is a little on the blind side, and so let's help it out by dragging from the Get Forward Vector node, typing the multiply symbol, and then adding a vector times float node, setting the float value to around about 400. We have done this work so that whilst the line trace will shoot a ray in the direction that the camera is facing, we have set a limit on how far that ray can travel. This will help stop the player doing something silly like being able to use the light switch while stood on the other side of the building. We are using a value of 400 here due to the scale of our scene, but this might be a little large, so feel free to increase or decrease this value once the blueprint is completed and you see its effect. We do also need to tell Unreal that all of this cleverness needs to be calculated from the camera's current position. Using the getWorldLocation node then, let's drag from its output, and then search for and add a vector plus vector node by typing the plus icon into the search field. So, although we have set up the direction and distance of our line trace, we still need to make sure that its start location matches that of the camera's current position, which is what the vector plus vector node is for. To hook things up, we can pipe the output of our vector times float node into the second input of our vector plus vector node. Adding the two together just ensures that the ray always travels 400 units from the camera's current position, meaning the start position value will update as the player moves around the level. Now, this just ensures a constant and predictable line trace each and every time. We will need these nodes to affect the line trace itself, and so let's pipe this into the end input of our line trace, and then pipe the original getWorldLocation node output into the start input on the line trace node. We've calculated the origin of the line trace, its direction, and its distance, which is the endpoint of our line trace, so that we can pipe this vector into the end input. The camera's current world location then will always be the starting point of the direction that we are looking. We use the original getWorldLocation node of the camera for the line trace start input. We are almost done with the line trace now. After dragging from the line trace node's execution output, we can search for and add a branch node, and then pipe the line trace's return value into the branch node's condition input. We have added this as a catch-all that will make sure that the line trace does return a value before continuing on with the flow. This branch will also help us split out the line trace when and if it comes time to use it for multiple interactions. Although we are not finished with the exercise just yet, we have at this point set up both the line trace that we needed and have also put the building blocks in place for the rest of the blueprint.